Good evening, everyone. I hope I am audible. Can I be acknowledged in the chat box? Okay. So, without wasting much time, let us begin with our slides. Uh, as I expect, we have done with this slide types of data models. Have we finished with this slide? So, some are telling that we have not done with this particular slide. Actually, as I remember, we have done with this particular slide. In the very last moments, we were there and we have done it in a hurry. Anyway, irrespective of whether we have done it or not, I'll try to just go through it once again. But it will be just a overview. Keeping it back for our remembrance, we have done with the instances and schemas. Instances are just like variables, and schemas define what those variables are going to contain. What is its structure? That means it's like a data type of the variables. So after that, we are going to learn about data models. And in this data models, first thing we discussed about what is a model. With respect to data, the model will be defining what is the data, what is the information that you are going to save, then what is the relationship with this or among various sets of data, then what is the data going to mean. I hope I have given one example of one numerical 1 which signifies in correspondence to our shift 1 or 2. It means which shift I'm talking about. Same way, when I say number 1, it may be a rank number 1, score number 1, or some marks number 1. So what is the internal semantics is also to be captured in the data models. Then certain constraints. I was giving an example of salaries of different persons. So those constraints, salary should not be less than 3,000, some limitations. It cannot be more than 1 lakh for imagination. So those conditions are nothing but the constraints that we were talking about. Then we went into types of data models. The first type, which is very, very important for us, which gives the design overview of a database, is nothing but the entity relational model. This entity relationship model is going to give a pictorial view of what the data is going to be stored inside. So without that pictorial overview, we cannot practically implement it. So when I want to implement a database, I have to first design it so that I can come to know, okay, what will be the relationship between different data, what will be the actual data that I need to save, all those aspects. So this will be the first model that we'll be learning, entity relationship type model. Then we will be talking about a relational model, trying to implement this design which we have designed in the first phase back into implementation storage format in our computer. Relational model is going to make use of tabular way of storing data in the table. As you can, as you know, there will be certain columns and there will be certain rows. So each cell will correspond to a particular row and particular column. Each block of value will correspond to a particular row and a particular column. Here, each row means a data corresponding to a particular entity, whereas each column will try to characterize different things about that entity. For example, if we take the database of students table, each row will signify each student in our table, but the columns, pin number, age, and then so on, marks 1, marks 2, subject 1, subject 2, so on, will characterize that particular student in that particular row. So a particular cell value, for example, pin number 003, is signifying a particular value for the row number 3 of the student 3 and is of pin number column. So like that, we'll have different things stored in relational model. Relational model is going to store the data in terms of tabular fashion, and each table will be composed of various rows, and each column will signify a characteristics among that particular row. Then we'll be moving ahead for object-based data models. Since we know that there are various languages which are going to make use of objects to represent the data rather than just variables. So when I want to integrate, link up my database to that object-based models, object-oriented models, I have to have similar characteristics as that of object in my database also. So there are certain models which are going to make use of objects to store the data. So those models are called as object-based data models. Next, we'll be talking about semi-structured model. Semi-structured model, as I was talking in the first unit, that XML is mainly used for translating one language format into another language format. So here we'll be using one structured format of data representation to be converted into another structured format of data representation. For instance, we talked about relational model, which is going to store the data in terms of tables. But in case of object-based data models, we are going to store the data in terms of objects. So objects are not internally tables. So I need to convert or have the linkage between the tables and the objects. To have that linkage, I need a middle layer which can translate them internally. That middle layer or semi-structured, from tabular structured to object structured, we need a semi-structured model which can act as an internal mediator between these two. So we will be using XML in that semi-structured data model. Then we'll have other models. Those other models are just going to represent the data in hierarchical model. One format linking with another format, linking with another format, forming a tree or a forest or such type of representation. Those are called as network model. Then hierarchical model is just a tree order representation of the databases. So I hope I have given this overview of this slide. Now we will be moving ahead for each category of data models. We will learn in detail what is going to come in the entity relationship model and relational model in detail. Then we will have an overview of the remaining one, because these two are the ones which we are going to use in our relational database systems. So coming on for a entity relational model, here everything is to be represented in terms of entities and relationships. Whatever data we are going to store in this model, we'll try to represent it in terms of entity and relationship. So let us first get to know what is entity and what is relationship. Anything that exists in this world and can be distinguished from other things is called as an entity. For example, a place, name of a place is an entity. A human being is an entity because one human being can be distinguished to others. A pin number is an entity. Anything that exists in this world and can be distinguished with others is called an entity. Relationship is association between different entities. So ER model, data model, is based on a perception of real world that consists of a collection of basic objects. These objects are called as entities, but main thing is they should be distinguishable. If two things are same, I'm not telling similar, they are same, then those two are not considered as two different entities. They are the same entity. And the association between them is called as relationship. So, entity is a thing or object in real world that is distinguishable from other objects. Symbol. A person is an entity. A bank account can be considered as different sets of entities. Bank accounts cannot be same. So when you want to describe an entity, you need to describe it in terms of attributes. These attributes are the characteristics which we use to distinguish among various entities. For example, when we talk about persons, if I want to distinguish among two different persons, I can characterize them or I can give them attributes such as name of the person to distinguish. Two students may have the same name, so we will try to attach one more thing called as pin number to distinguish among them. There may be marks if I want to distinguish among them. There may be address where they live. So all those things are called as attributes. So entities are described with a set of attributes. One example I have kept over here, for example, account number is and balance are used to describe particular account in a bank. So relationship is association or the linkage between various entities. Depositor is a relationship among customer with a account number which he or she has. Okay. Now, a set of different entities which have similar attributes. Set of different entities which have similar attributes is called as an entity. Same way, a set of relationships which are having similar characteristics, similar attributes is called as relationship set. So when we want to make use of ER model, we'll have pictorial overviews. When I want to draw something, I need some notational formats. I cannot draw without using certain notations. So here also we use certain notations to depict various things. For example, we will be using rectangles to represent entities. We'll use ellipse to represent their attributes. Diamonds will be used for representing, sometimes also called as rhombus, is used for representing relationships among various entity sets. And lines are used to just link them up together. So we have various other representations which we'll come to know. For example, in ellipses, we have different types of ellipses. Rectangles, we have got various types of rectangles. In diamonds also, we have got different types of diamonds. In lines, we have got various types of lines denoting various things. So all those things we will be trying to see one after the other. But one before we move on for actual diagrams, one more thing which is very important for us is mapping cardinality. Mapping cardinality actually denotes how many entities are going to participate in a given relationship. A student entity set is one thing, a college entity set is another thing. So when I want to have a linkage between these two, I say there is a relationship that student studies in college. So when I say student studies in college, how many students can study in one particular course? There is a limitation. A student can study in one particular course. Same way, a student is studying a particular subject, a particular classroom, in a particular classroom. So when I want to say that a student is studying in a particular classroom, there is a limitation that up to 60 students can study in one given classroom. So all those conditions are called as mapping cardinalities. So mapping cardinalities express the number of entities to which another entity can be associated via a relationship set. Coming on for one example, without this example, we cannot understand anything that we have talked till now. Just have a look on this this ER diagram. Here in this one, I have got two rectangles. These two rectangles are two entity sets. One of the entity set is customer entity set, which will contain a set of customers inside it. Another one is a entity set of account. It will contain a number of accounts that are there. So these two are linked together using a relationship called as customer deposits in account, or customer is a depositor for the account. So when I want to describe this customer, I will describe them using the customer ID, customer name, customer's living street number, customer's city. Same way when I want to describe these two account, I will describe it using the account number and balance. So just this tutorial overview is the ER diagram. With this diagram, we'll come to a conclusion that, okay, there are two tables to be created. Minimum number of tables that are to be created to store or represent the data is two. One is the table which will contain the details about the customer. Another is the table which contains the details about the account. I want to write that particular table or create the table. I need certain columns to represent what are the values that are going to be stored inside it. So when I want to create the columns, okay, I will look at its attributes now. What are the attributes? Customer ID, customer name, customer street, and customer city. So when I use these as the column names, now comes the rows. For each customer, I will make use of these values to define that customer. So there may be 60 customers or 1 million customers, but all will be defined using these values. Same way when we come into account of this account table, we have got account number and balance, which will act like two columns, and each row in that account will correspond to each account in the bank. So there is one more relationship coming in between, which is depositor. If needed, we'll make use of a table to define this depositor, but usually we'll not, just to keep our database short and clean, we'll not use much tables to represent relationships, but if needed, we'll do it. Like how we have defined the entity set customer with the help of certain attributes, we'll also define this particular depositor with certain attributes. We can do it. If needed, we will do it. So coming on for relational model is going to make use of table as I have told you, and it contains certain columns which will describe that particular entity set. Now, these rows, one row, each row defines one single entity. Values will define what is that entity. Look here, if you take into account all of these, no other row will have the same data. For example, no other row is going to have the same ID, same name, same department number, and same salary. This is a compulsory thing in relational model. No row should be exactly as it is, because the definition of entity is an entity is anything that exists in the world and can be distinguished from other. When I want to say that it can be distinguished from others, there should be something which makes it unique from others. So these rows define what is an entity, and these columns are the attributes of those entities. So simple thing revolves around the fundamental data structure called as a table, which is the formalization or intuition notation of a table. Now the class of the data structure that we refer over here in relational model is tables, sometimes also called as relations. Now talking about relationship, relations or tables are one and the same, but to not to make it confusing, I'll be using tables, but internally it also means relations. Now these relations, when we have the numerical values or physical values inside them, we can apply certain relational algebra to it, certain calculations. Like for example, if I have got over here salary is there, if I want to say that salary is just the basic, and the actual one which is to be given to the user is to be included along with it a housing rent allowance. So I will have one more column over here, HRA. And now when I say net salary, I will try to add this basic salary plus HRA and give that particular as the net salary. So this addition is the relational algebra that I am going to apply onto it. So you can also impose certain constraints, which we have earlier learned in all these things. So in short, table contains multiple columns and each column has a unique name. A sample one, just I have kept over here. Now, uh, when we have AR model, why are we going to have this model? This is one doubt. For simplicity, AR model is just a designing phase. It's just on paper or in a computer like like a picture. But if you want to store the data, you need to represent it internally in terms of computer understandable format. In that computer understandable format, you need to store in terms of variables, and each variable will have its own data type, and that variables, when they are stored together, should have a particular structure. So that structure over here is the table. The variables are the column names, and they will have certain values. But whenever you are defining those column names, you need to see what type of value can be stored inside it. For example, here all looks like numerical. So I will define this ID as a numerical. Over here, all are characters. So I will define this name as the character database. So that is one thing. Now, relational database languages, when we want to make use of these tables to be represented internally, I said we need to represent it in terms of computer understandable formats. So to speak with the computer, we need certain languages. So in case of databases, we have got various categories of languages. These languages are not different set of languages. They are a part and parcel of the same language, but they perform different categories of actions. For example, one set of categories is defining the data that you are going to store. That means, as I said earlier, I'm going to tell that here is the table called as instructor. I'm defining that instructor is a table, and that table is going to contain 1, 2, 3, and 4 columns. And the names of columns are ID, name, department name, and salary. And the type of the values that are going to store, or the data type of this ID is numerical, data type of this name is character, data type of this department name is character, salary is numerical. When I'm saying all these things, I'm actually defining them. So one set of commands in the language will be used for defining the data. Another will be used for manipulating the data. Manipulating in the sense, as I gave the previous example, salary is over here. Let us consider this as the basic salary plus HR. If I want to add them together, I need a plus symbol in between them, some operational, relational operation. So I cannot sit down and calculate what is this plus value and then add on that value. Computer has to do it. So there are certain commands which will perform those tasks, and those commands are defined in manipulation. Not just that, we can even, for example, by mistakenly this physics got typed wrongly. So I need to correct it. I need to rename it. So for renaming or manipulating it also, we will be using certain commands. Those commands are coming as data manipulation language commands. But all of these commands are a part and parcel of the same language, which we'll be learning called as SQL, sequential query language, or sometimes nowadays called as standard query language. So there are different categories of languages based on what action they perform. Secondly, there are certain classifications among those languages from a perspective of whether they can be used free of cost or whether they are commercial. If we can use them free of cost, then they are called as pure languages. If we have to pay for their usage, then they are called as commercial. Pure languages are a little complex in writing because we need to define what is there to be done in detail from our side, which as a normal learner cannot do it. So we need to make use of certain things which have been already defined, which computer can understand directly, and those are given by certain commercial uh, companies like Microsoft or Oracle or so forth. And to use it, we need to pay. Some of these companies will give it free of cost for practicing and for students' sake. But when we try to use them same product in a company, we need to charge their charges. But there are ways which we can define completely from the scratch from our side and we can use it. For example, C language. In the pure type, you will be defining the compiler, what are the keywords, what are the operators that are to be used, and then you will be using that particular language, which becomes very difficult for the learner. But if the compiler is already available, you just need to learn, okay, what are the various keywords that the compiler can understand, what are the various commands to execute the program and compile the program. So those type of things were already defined by some commercial companies and they have been released as SQL, which is very widely used. So whether we can go for pure or commercial, there are certain things which we have learned earlier which come as a basics. So as I said, these two things are not two different languages. There are two more, like data definition language command, data manipulation language command. We have got data control language command, transaction control language command, which contains different sets of things, commands, which will work on different categories of actions to be done. So we'll be learning all those things one after the other. As I said, just listed here is it listing, but we'll be learning them in detail in the first unit as well as in the second unit. Don't worry about it. We'll be learning few commands in this one and in the data manipulation language command, in data control, and data transaction control. All we'll be trying to learn. Moving on for a brief overview, what I have spelled out earlier. Data definition language command actually defines what is the data to be stored inside. That's why it is also called as data storage and definition language command. This contains certain commands which is very useful for the user to define the data. Once the data is defined, then we can store certain information inside it. So once it is defined, it is not visible to the user. Only what is visible is what are the values stored inside it. So these schemas which we have defined using them are usually hidden from normal users. So in the schema itself, we can define certain consistency constraints also. For example, while creating this table, let me go back, this one, salary, I can say to the SQL compiler that whatever values are going to be entered here should not be less than 3000. So at the time of data definition itself, you can specify certain constraints and those constraints will be looked at as a consistency constraint. One example for creating of a table. It's very simple. Create table. These two are keywords, are fixed reserved words. Instructor is the name of the table and it was containing 4 columns inside it. One is the ID. As I said, ID was containing numerical, but here I have used character. You can use anything. Char is one of the data types. Name was one more column and we have defined it using variable character of 20 length. So it can contain maximum of 20 characters inside it. Same way department name, it is also a variable character and it is going to contain 20 characters at a given moment of time, maximum. Salary is numeric and it contains maximum of 8 digits inside it, out of which 2 digits are after decimal point. So 6 digits before decimal and 2 digits after decimal. So this bunch of code is called as a command, is called as a single command. It is starting from here and this parameter listing is ending over here. And this is set of things that I have listed in between the parentheses is nothing but the name of the column along with its data type. So when we apply this command into SQL prompt or SQL compiler, it will create a table for us with the name of instructor containing 4 columns. So DDL statements creates the instructor table, likewise account table. Whenever we apply this particular command, it actually does 2 things for us. One is it tells the compiler that whenever the word instructor is going to come into existence, that instructor means that it's a table containing 4 columns and the names of columns are so on and so forth. with so and so values that can be stored inside. So this meaning or semantic will be stored inside another meta table called as data dictionary, or sometimes also called as data directory. Whenever next time instructor word is typed in the SQL prompt, the SQL compiler will look into the data dictionary and get to know, okay, what is this instructor? It's a table containing these values. For instance, I have typed another new word. Compiler will go and check in the dictionary. Is there any corresponding structure defined to it? Is there any corresponding schema defined to it? If it is available, it can understand and interpret what I'm telling with that word. Otherwise, it cannot determine it. So, a data dictionary is very important. It contains the following things. First thing is the schema, what it is going to contain, what is the name of the table, how many columns are going to contain, what are their data types. Second thing, what is the integrity constraint? When I want to say that this is a table, I said earlier that the number of rows that are going to contain in the table, in each row, there should be something which differs from the other row. So each row should be unique for one entity. So that value which is going to uniquely identify each row is called as a primary value. And the column which contains that value to uniquely identify each row is called as a primary key. So this data dictionary will not just contain the name of the table, it will also contain what is the column name which is going to contain the unique values to uniquely identify each row, or so called as primary key. Next one, who can access this one? Because earlier we said one of the drawbacks of file system was security reasons. So here we'll have complete security and we'll define who can access what type of information inside it. For example, salary should not be accessible by all. Whoever may be the employee, if they are trying to access other person's employee's salary, it should be blocked. So like that type of restriction can also be made who can access what type of information. So in general, data definition language will be defining all these type of uh, definitions. Now, when we come across data manipulation language commands, these commands are meant for performing these four actions mainly. First thing is it is used to perform to access or see what is the information stored inside the tables, also called as retrieval of information from the database. Second thing it can perform is if I want to store any new value, for example, a new employee has been joined and I want to just take the existing table, I want to insert a new row. So for that one, we'll be performing insertion operation. Delete is going to delete a particular employee's record. So for example, an employee went off and I want to just remove that particular information. So I need to delete the entire row. To delete it, we'll be using deletion operation. But the employee was upgraded, the salary was modified from let us say 6,000 to 8,000. So that is not deletion, that is modification or updation. So for modification or updation or renaming, we'll be using modification commands. So we perform these four different actions for using the data manipulation language commands. So it's the language that enables user to access or manipulate the data as organized by the appropriate data model. There are two types of commands in this one. One is pure, second one is little commercial, as we discussed earlier. With regard to pure, it's completely procedural. In this one, we need to say step by step to the compiler what is to be done. Right from the scratch, we need to tell what is the data to be accessed and how that data should be accessed. Both the things should be told. But in case of declarative, it's not like that. We'll just say what is to be retrieved or what is to be done without telling how it is to be done. So these declarative statements are given in SQL. SQL falls under declarative DML language commands. Procedural will be learning in the fourth and fifth units, a little bit of it, but it is not completely procedural. We'll learn few of it. So, DML component of SQL is non-procedural, as I said, non-procedural or declarative. So, whenever we write any command to the computer, we are just telling over here what is the data to be retrieved or manipulated, but we are not telling how it is to be done. So, when I say what is to be retrieved, I'm just querying for that data. I'm just asking the database to give me that data. So that is a query. That's why sometimes we call all these statements of declarative nature as query language statements. So in simple, query is a statement requesting the retrieval of information in the portion of DML which involves the retrieval of information is called as query language. So coming next, SQL query. This SQL query is a statement, is a command. Earlier it was called as sequential query language, but now it is called as standard query language because different companies were having their own sequential query languages given out. And for a developer, it was becoming very difficult for learning different companies, different syntaxes. So all of the companies gathered together to give a unique standard commands, which will be common for all the different types of companies. And this standard notations, which were followed by all the companies, was called as standard query language. Earlier, it was instead of telling it as sequential query language, most of the people still use the word called as SQL. So this SQL or SQL or standard query language can be embedded in high-level languages, as we'll be seeing it in the 8th and 9th unit of Java. When we try to use the SQL commands in those languages, we'll call them as embedded SQL there. And we'll try to link the database using ODBC or JDBC. We'll see in detail with the help of 3 to 4 programs there. So looking into the sample query, here I have kept one query. Select customer name from customer. So you can see over here 2 times customer is coming. This customer is the name of the table. And what I'm trying to retrieve from the table is the column customer name. This customer name is the name of the column. So when I want to say the computer that or the SQL interpreter that give me the name of customers who are available, I need to tell from which table I need to get that customer names. So I will write customer, that is the name of the table, dot is the operator over here, name of the column that I want to use, from where I want to retrieve the values. But in addition to it, I need to write from as a keyword and write the name of the table. Look here, one important thing over here is this customer given in green color is optional, because here itself clearly we are telling that these names should be retrieved from the customer table. But let us imagine we are trying to retrieve the value from 2 different tables containing the same column name. I'm telling that take the name of the student from biodata table as well as a results table. Same here also name is there, here also column name is name. So computer becomes confused which name should be popped up. If I clearly say select result.name from results comma so and so biodata, then it can understand that okay, I need to select the data from that particular table. So here is the query, but you can shorten it, filter it. I don't need all the customer names. I need a particular matching criteria. I need only those customer names which are having an id equal to so and so for value. So this where is the clause, CLAUSE clause, which is applied to filter out whatever results were being given out from here. So again repeating, select is the keyword, from is the keyword, where is the keyword, and equal to is also a reserved word. That's why I kept all in red color. Whereas the customer over here is the table name, which can also be used in combination with the column names here, just to clarify what is the column name to be selected from which table. And here is the value that is to be selected. So Let us see, this is the table. What can be the value selected out? So compiler will try to see, okay, select, what to select. Name, from which table? Customer table. Okay, customer table is available. Customer name is a column, yes, available. So these many values are there. But wait, there is a clause where customer ID is equal to so and so value 192837465. What is that corresponding customer name? Johnson. So what will be the result written by this query? Johnson. So uh, one I'll give one example and end my task query. What will be the result of this query? You need to figure it out and keep it as a message in our classroom. Or else you can try here itself in the chat box. I'll be waiting for it. With this slide, we'll end our class. In 5 minutes, it is going to end. Just try to look at this particular query and answer back. A1 not one, Bala Subbarao. Anyone else? Okay. Let us try to understand this query first. We are trying to select balance from account table. So is there any account table? Yes. Is there any column name balance? Yes. So we are talking about these values now. Okay. From this, something should be selected. Fine. From this, from depositor table, is there any depositor table? As well as account table. Account table we have found it. Depositor table is also available. So these two are available, but we are talking about only selecting these values. So we should get something from here. But wait, there is a clause depositor.customer ID. Is there any customer ID? Yes, here it is. Should be equal to so and so. Okay, 192837465. Yes, it's there. And depositor.account number. Depositor.account number is equal to account.account number. Okay, we are talking about what value now? This one is 101. Is there any A101 here? Account number? Yes, it is there. So what is its balance? 500. So what will be the result of the query now? 500.